Welcome everyone to the Polarian series of webinars. Today's presentation, 3D printing. How is it revolutionizing your product development? Our presenter today is Nick Entin, the VP of R&D for Polarian Software. Nick has over 15 years of experience in software engineering and is responsible for all aspects of Polarian software development. Prior to Polarian, Nick held senior positions leading ALM development strategies, as well as he lectures for computer science at the University of Physics and Mathematics in St. Petersburg, Russia. Nick holds an MS in software engineering from the Electrical Engineering University of St. Peters. Welcome, Nick.
Thank you very much, Nancy. Welcome, everybody. I would like to speak today on a very exciting point about the 3D printing, how it changed our life, how it changed our industry, how it changed our products. In the first place, I would like to say a couple of words about our company. We are a privately held company founded in 2004, and we are a very dynamic and young company, and our web-based ILM and requirements management and quality assurance products are very innovative, and we consider them to be the best worldwide. Our first release happened in 2005, and since there we are very successful on our market. The company is very international. Here you can see some map of the coverage of our businesses. We have the principal offices in Germany, in the United States, in France, in the United Kingdom, in Italy, in Czech Republic, and Switzerland. And we have the partners in all strategic markets around the world. Among those, we have very strong presence in Southeast Asia, China, Japan, South Korea, Taiwan. We have a good presence in Scandinavia. Actually, we cover all the Europe area, Austria, Spain, Netherlands. We have a good presence in South America, so Brazil, Chile. We have presence in Australia and South Africa. So wherever you are, you can contact us and find our local representatives. So let me go to the focus of our solutions. Polarian is offering an application lifecycle management solution, which is called Polarian ILM. There are two small pieces of our software, so it's feature-limited products which are requirements management, only for the companies who are interested in explicitly requirements engineering, and quality assurance products. The main focus of our tools or our solutions is guaranteed traceability. It means that all the artifacts, what you manage during your product lifecycle management, application lifecycle management, should be traceable in terms of linking between items, between the historical aspects of this, making sure you know who, when, and why did the change. Also, such aspects like digital signatures are supported by our software. For disciplines like requirements engineering or specifications or test management, quite a lot of customers require they are assimilated to use of Microsoft Office. And since we are offering a web-based solution, we are somehow competing to the online collaboration of Microsoft products. And this extent, we don't want to compete with them. We love to friend with them, to make a friendship with them. Therefore, today, Polarian is offering out-of-the-box round-trip engineering with Microsoft Office formats without one of the limitations and shortcomings. And the third point for our products very important is that it supports any kind of processes and methodologies. Particularly, many of our customers are coming from regulated environment. It means that the customers they have to certify their processes. They need to comply to different kinds of regulations and rules. The tools which they use in their development processes, they should support them. And of course, Polarian has a very good support for traditional methods of development like V-model, like waterfall, as well as a modern and dynamic methods of development like Agile. Particularly, we internally use Scrum for our software development, and of course, we are sharing our best practices to our customers. So let me switch to the main topic of today's presentation, where the 3D printing is today. Is it a subject for the future, or it's something what is around us already today? Many industries already set on 3D printing, especially it relates to the industries who have a demand or who have a need to develop individual items. Very easy to see it in medical development. For example, there are companies like the companies who produce all kind of prostheses, replacements, for example, tooth replacement or bone replacement, or tools, medical tools which will be used, and these tools need to be adapted to the concrete person who is a patient at this medical station or services. Here we have a lot of practices and currently Polarian customers already setting up the 3D printers for their needs. Aerospace and automotive, they have a huge potential for 3D printing in all kind of modeling. So when they prototype the first models of their new aircraft or cars or any kinds of parts of this existing aircraft or cars which might be improved. Of course, it's easy to produce an individual part with a 3D printing because of the values which I will note in the next slides, and try them on existing real cars in a real environment. The defense guys already setting up the 3D printing because they have realized that, for example, for US Navy, they consider to install 3D printers on Navy ships because instead of keeping the supply of all potential replaceable parts, they can carry just a printer with a set of the supply materials which can print the required part on demand. And of course, last but not least, the consumer manufacturing. This is what's around us in our, so to say, in our personal environment. We can see quite a big, so to say, boom there. For example, this morning I visited a German Amazon site and counted more than 10 different models of 3D printers already available for household. Pretty affordable, starting from 700 to 2,500 euros per model, depending, of course, on the quality and features of the device. But taking account the price for the supply materials, it's already somehow competing to the pieces what we eventually need at home. I will touch this subject a little bit later. Let us speak about unique value what 3D printing brings us. First of all, that it's low cost and time of the initial production. In one of the next slides, I will speak about the traditional PLM, so product lifecycle management, where you need to forecast the price and the process and all kinds of costs associated with engineering of your product, starting from idea till to the ordering of a supplier who will manufacture your product according to your specification, or to build their own factory to produce the things. And with the 3D printing, you can, in the first place, really disregard all this cost associated with production. You just need a 3D printer, and you might be sure that the first object or the first part what you want to produce will be ready at once as your digital specification will be ready. The 3D printers are already affordable even for individuals. Of course, there is commercial, industrial printers. They are pretty expensive, but the ones what we can use at home are already pretty affordable. I mentioned about the German side with 700 euros. With the American dollars, it's even cheaper. So in US, the 3D printers, as usual, for any kinds of electronics, they are cheaper. The next point is that the 3D printers are very flexible. It means that you don't need to reconstruct or reconfigure your robot or your CNC device or your band to produce a new kind of the part. You can just upload a new digital model and the 3D printer will be able to print it. So you can really print as many different parts on one device as you wish. Related to this is adaptable, because earlier for the band manufacturing or CNC manufacturing, typically this is a kind of a production when you need to manufacture thousands of pieces of the same size, actually the same pieces. With a 3D printer, you can evolve or improve your design in time. So each new improvement of your digital model you can upload, and immediately the 3D printer will be able to produce a better detail. Of course, because of the affordability and flexibility and industrial setting to 3D printers, the tool manufacturer, the ones who are working with CAD systems, who prepare the CAD system, they care to lower the requirements for the skills of the end user. So principle, in the future, I believe that everybody should be able to use the 3D printers. It means that they should be able to build their own 3D models and upload them to printers. The first sign of it is already there. Microsoft recently announced that a new application for the Windows 8.1, which allows you to model and print models. They have even a catalog of ready templates. Majority of them, of course, relates to some toys for home, but this is very exciting. I mean, that I would be happy to have one of them at home to bring a new railroad for my kids or so. I want to bring a couple of interesting facts about 3D printing. There is quite many different materials already available for the 3D printers. If a concrete model can print a plastic, typically you can easily get maybe 3-5 different types of plastic that this printer can consume. But generally, there is already 70,000 of different materials available for 3D printers. I already mentioned about this approach of the U.S. Navy to install printers on ships, and this relates to many other industries as well. For example, NASA considers to send the 3D printers eventually to other planets. So can you imagine that the Curiosity will have a 3D printer on board and will be able to print eventually a second Curiosity next to him? This will be interesting. By the way, there is already at least 2 known to me projects of making 3D printers capable to print themselves. So one of them is very popular. We can find it on Wikipedia, called RepRap, and this is a printers who print the new generation of the printers. In the meantime, there is already 3 generations of the printers prepared in the scope of this project. I've spoken about the availability and affordability of 3D printers for home applications, and quite important, of course, about the supply materials. My personal concern earlier was that, okay, you can buy a 3D printer, but you need to order the supply materials over the internet with a high price and stuff like that. But it's very surprising to understand that actually today the plastic supply for 3D printers, for home application 3D printers, is available in electronic shop already around the corner. Particularly here in Germany, the 1 kilogram of plastic costs just 25 euros. So from 1 kilogram of plastic I can produce 1 kilogram of toys. My kids will be very, very happy, and I will be happy because I will save a lot of money. Let's speak a little bit about today's limitations. I would consider 3 limitations for 3D printers. First of all is the size of the model they can produce. For the consumer models, typically they don't exceed the dimension of 20 by 20 by 20 centimeters. Many of them are even smaller models. For industrials, it's bigger, but I have not seen bigger than maybe 1 meter by 1 meter by 50 centimeters, something like that. So still, the dimensions of objects which could be produced by 3D printers is limited. Second thing, that they are still relatively slow. I mean that the time of output of a piece is counted in hours. So the typical speed of the printing is something like 15 millimeters per second. So you can take many hours if your object is complicated. And if you need to produce hundreds or thousands of elements, probably you will go to a traditional manufacturing method. So you will order it by some fabric, which prepare some sort of band, or they will use CNC devices to make this serious manufacturing. Dependency on material, on kind of material. At the moment, there are printers which are capable to print out of plastic. Others are in metal, but it's hard to find a model which could print simultaneously metal and plastic, or the plastic printers which can print simultaneously of plastic of different colors or something like that, or different kinds of plastics. By the way, interesting remark that here the screenshot with the dental services. This is a screenshot from one of Polarion customers. It's a Sirona company. It's a medical company who is really focusing on dental tools and software and so on and so forth. They're already using 3D printers to make the tooth replacements directly on site when a patient comes to a dentist, and he is scanning the teeth and prepare the replacement in a matter of minutes. Let us speak about the classical product lifecycle management. So when we speak about mechatronical product development, 3D printers may bring quite a lot of changes there. Let's speak about the process, the typical process there. Of course, this is a simplified schematic here, but many of you could recognize basic steps there. So you start with an idea, then you go to a feasibility proof. You need to do some research if your product might be manufactured, if it could be a profitable thing, if it makes sense to invest there, and so on and so forth. Then you do the advanced development where you do the piloting, prototyping, and stuff like that. Then you go to the product engineering, which is typically associated with the CAD development, the design engineering, and you go to simulations to check how exactly your model appears in the real environment. When the things are ready, you go to the productions process engineering. So you really need to provide your specification and prepare eventually a bench or a set of robots, or you need to order some partner to produce models according to your specification. And then, of course, it goes to a typical process of preparation for sales, procurement, real production. So you're sending an order to your partner to produce 5,000 pieces of this detail, then you deliver to your customers. Then eventually your product will be retired and you need to consider the end of services, which means that you need to produce further and further the details for the customers under the warranties, and then it goes to recycling and to the end. And principally, the 3D printer may bring you the following benefits. First of all, that it could shorten the time for the production. So this is the central piece when the factory itself is involved. So you can really start manufacturing the first physical element, so the first physical part, without even contracting anybody. You can have just a 3D printer next to you, and you can manufacture this part yourself. When you will be happy with this, of course, you can go to the traditional way of manufacturing and make processes. Of course, it could also mean no time for production engineering process. I mean that because of you can produce the first final product yourself, you can spare the time on the definition of the production process engineering. And only when you ensure that the profitability of your product will be ensured because you produce so great piece, then you can go to this process engineering and the real production. Another point is that today majority of the automotive, medical, aerospace, defense, I think we do need to simulate our design. So there is a huge bunch of software tools which allow you to simulate your design, your objects, to check. For example, if you are producing a tire for a car, you can simulate behavior of this tire. You can virtually run a car for 50 kilometers and measure the temperature of this tire at the specific place. Unfortunately, not every company can afford the simulation tools, and maybe for some of them, at least for small and medium-sized companies, the 3D printers can somehow replace the simulation tools. You can really make a prototype, the physical prototype, with all the properties of the final product, and you can test it in real environment. So you can really put this tire on the real car, drive 50 kilometers, and measure this temperature yourself. The next point is the flexible production with easy production of variants. It means that really you can change the flow of your production with the different variants. You can print one object, you can easily improve it and print another variant, you can do it in parallel. The next point is production on site. It means that when you're ready with your design, it's not necessary even to have a 3D printer next to you. You can really send the digital design to anybody who has a 3D printer. Maybe it will be your customer. So instead of preparing this detail on your site and sending the detail over a post, you can send the digital model and the customer will print this detail according to your design on site. And of course, this is quite important for end-of-service production. Many companies have a plug of necessity to keep the replacement for the already retired products. And with the possibility of 3D printers, they would be able to print the details of these parts on demand when the warranty case happens and when the particular customer needs particular device. Let's speak about the aggregation or somehow cooperation between product lifecycle management and ILM. So in the product lifecycle management, typically we consider the mechatronical, electronical development and less about software part. Today, many industries already recognize that the software plays a very significant role. As a reference, in Mercedes S-Class, there is more lines of code than in passenger aircraft. So it means that when they do the Mercedes, they need to consider quite a lot of aspects of software. They need to ensure that the chips, the electronic chips which will run this software will have the corresponding performance. They need to measure the purchase of that the environment will be sufficient and stuff like that. The more closer the software with the hardware development will be, the more beneficial it will be for the corresponding industry. And we have different patterns in software, particularly the software in last years moving more and more to the agile ways of development, because we know that the requirements are changing, that the demand of the customers and market are changing so rapidly that it's better to have a flexibility in the development process. With the mechatronical part, it was not so easy because of these complicated processes. You need first to create a final design, and only then you can really go to the production. And of course, it takes sometimes months, sometimes years, and you cannot be so flexible as we can be in the software. With the 3D printing, however, it might shorten the development cycles. It means that already today we know the facts. For example, Nike, the shoe manufacturer, the sports shoe manufacturers, they are shortening the prototyping of new models from several months to just a few weeks. So they are already going to this iterative development. So we can bring the software and hardware parts in parallel, and this can bring the agile values to this kind of development. First of all, transparency, that everybody knows where we are. It's not long-term planning, it's not long-term execution. By end of each iteration, each sprint, which might be maybe 1 month long, might be a couple of weeks, might be a couple of months, but at the end of each iteration, you would know where you are. Empiricism, by end of each iteration, you will know what to show to the customer. You will know how will be the reaction. You can collect the feedback. You can collect the experience about that, and you can reflect this empiricism in further development. You can do refactoring of your product and improve your product over the time. Integrity, as I mentioned, if you bring the software part together with the hardware part, and by end of each iteration you will be sure that they work smoothly together, it delivers automatically the integrity of your final product. So you will be sure that there will be no surprises short before the final release. And of course, delivery. As I said, for example, Scrum ensures you that by end of each iteration you have potentially shippable product. Every time you can show it to your customer, every time you can try it, and so on and so forth. From other side, this 3D printing and the new approaches, how the models might be composed and how they might be executed in the production, brings us to the idea of a social PLM. Traditionally, the hardware manufacturing are subject for big companies who may allow themselves to operate on CAD systems. They are able to operate on the bands and CNC devices and robots and whatever and so on and so forth. With the 3D printing, it simplifies a lot of aspects, and it goes in the direction of socialization. Principally, you need a digital model to produce anywhere, so you are not anymore dependent on the availability of a factory. It stimulates reuse, so you develop it once and you can distribute it everywhere. And lower total cost of the engineering, because in the engineering phase you don't need to consider the production phase, production engineering process, and so on and so forth. Instruments to produce digital models are improving. It means that more and more people will be able to contribute here. It's not anymore so exclusive skill that the person who can build these 3D models, who can manufacture the real physical components, require a high education about that. Eventually, the Microsoft Windows users will be able to use such tools. So the more people are involved, of course, the bigger potential that very smart people will be involved, and the smart people have a great idea. So you will see quite a lot of interesting models flowing around. The social networking stimulates cooperative development. So it means that once you put this digital model in some shared environment on the internet, very likely that somebody else will find your model interesting and even will be able to improve it. So you will be beneficial because you prepared this model for yourself, but next time you will be able to replace it by even better things because of this open contribution to that. Open sourcing is very useful practice now in software development. Very likely it will be applied to the hardware development with help of 3D printing, because this sharing of the common results and contributing from the big community will accelerate development of the things. You will have very useful things prepared by the big communities, and believe me, there is a lot of enthusiasm in open source in software, but I'm pretty sure for modeling and manufacturing of house-related objects, I'm pretty sure there will be a lot. So let's speak about us. What do we offer as a Polarion? Polarion is a software company. How do we relate to the 3D printing? First of all, that we have very extensive expertise in application lifecycle management. As I mentioned before, we see quite a lot of overlap with electronic development. By the way, I need to make a note here. When I've spoken about this printing and physical manufacturing, more I've spoken about mechanical parts. I'm not so convinced that the 3D printers today can help significantly in electronic parts. For example, I know that there are 3D printers capable to print the electronic plates, but I'm not sure that there are printers who are capable to print chips or put the chips on the plate. So it's still some kind of improvements which are in front of us, and we will benefit from it. So here I'm speaking about more mechanical development. So the Polarion has an expertise there. We bring a lot of our expertise, especially in agile methodologies. We can help our customers to manage their projects, digital projects, so all the kinds related to the preparation of models, preparation of design, definition of specification, post-processing of the manufacturing. I mean, there will be feedback from beta testers, there will be response from the end customers, and so on and so forth. Polarion is currently working on PALM, so Product and Application Lifecycle Management Initiative. We want to bring together these two areas to make the traditional industrial manufacturers to keep care that the software is playing a significant role there. And it's better than when these two areas will be in some kind of partnership between them and not very isolated, like to big extent it looks today. And of course, we are working ourselves on the extending our product capabilities, embedding know-how, embedding new technologies, new features to support innovative technologies like 3D printing. By the way, on this slide, this is a picture of the RepRap project. I mentioned about this is an open source project for the 3D printers, and this is the version 1 of the printer, and with help of this printer, it produced the second generation of this 3D printer, which is on the lower part of this screen. Many of our customers are already setting up on the 3D printing, but I would like to highlight that Polarion is working with customers from very different industries and verticals. We have quite a lot of customers in aerospace and automotive areas. We have medical customers, we have telecommunication customers, we have services customers, and so on and so forth. Some of them you can see here. And if you find this webinar interesting, I would like to invite you to visit our website to check our solution. You can try it live, you can download it if you like. The 30 days license will be sent to you automatically, so nothing complicated. You can request proof of concept and watch a demo on our website. And I also want to announce that a couple of days ago we have released an ebook on the subject of this call. There are a couple of additional points which I described in this book in regard to the 3D printing and how it's revolutionized our environment. Stay connected with us. Thank you for joining us. And now I'd like to switch to the questions and answers session.
Great. That's a fantastic presentation. Thanks, Nick. We do have one or two questions here that I can present to you. The first one came in early in the presentation, and it just wanted to understand more the impact that 3D printing will have on their ALM process.
Directly, the 3D printers will not have an impact on application lifecycle management. I mean that application stays or usually associated with the software part. So in ILM, of course, you have a lot of things which impact the 3D printing eventually, because in ILM, you will manage your design, so you keep the models available, you keep your requirements for the models, you keep your defects if there will be any found. And then, of course, you can reflect these things. For example, ILM can stipulate the collaborative work on the models which will be then printed on 3D printers. But not opposite way. If there is a 3D printer or there is a CNC device, for us, at the moment, there is no big impact.
Okay. Thanks, Nick. I have another question here. It's a little detailed. We're looking to manufacture some custom connectors for circuit boards. I would require something about 2 millimeters in pitch for about 102 pins or so. Is a 3D printer able to get that kind of resolution?
Yes, I think you can just Google for that. Very recently, I mean, I saw the article maybe a couple of days ago. One of the guys have printed with an industrial printer a Colt M1911, so the real pistol, so the real weapon, the metallic weapon, and the industrial printers have a resolution of 20 micrometers. So I think for your purpose, it should be a good resolution.
Okay, thanks. Nick, I have an additional question as well. Could you develop these models using AutoCAD, or what other types of hardware models would generate this digital design?
That's a tricky question. I'm not an expert here. I'm not a 3D modeler myself. I'm pretty sure that from AutoCAD or from CATIA or any very big software, you will be able to produce the models which will be printable. But I don't really know what kind of software exists today for this modeling. There is a lot of, so to say, proprietary projects. So you can use the software manufactured by small companies for modeling like that and sending the produced models to the 3D printers. Unfortunately, I cannot answer concretely to this question.
Okay, that's great. The registrant's quite happy with your answers. I don't have any other questions in the Q&A if I reach out to the group to see if there are any additional questions. If there aren't, and I would just like to remind everyone to complete the survey that you'll be receiving automatically at the end of this webinar. That you will also be receiving the audio link with today's presentation, and again, we hope that you will share that with your colleagues. And to please look for us on the Clarion blog. It's really worthwhile reading. And since I don't have any additional questions, again, Nick, thank you very much for your presentation today and for all of you who joined us. Thank you.
Thank you very much for all attendees for your attention. Thank you. Have a good day.